Hello, everybody, and welcome to today's vOLTHA TST meeting. Thanks for joining. As usual, the call is public and recorded. Will be shared live on YouTube, so please be mindful of the comments you make and the information you share with the group. First order of business today, just want an update to give an update to everybody on the Kafka to gRPC swap, where we stand, and the work that David did mostly last week. And possibly some more updates from Ken, given that he should be back from vacation. So, David, do you want to take it on and give us some thoughts?
I mean, last week was really just more of an investigation, trying to figure out. I fixed a couple little things. The real works, still getting 2 test failures around the core restart. We think Teo's done a lot of work, as have others. It's a rule flow ordering issue that we're still dealing with, and with regard to barrier issues as well and how they're handled, and some of the multi-threadedness or go routines and concurrency issues within the core and OF agent. So those are the areas we're kind of investigating right now to make sure messages are being processed in the right way.
Yeah, just to be clear, I'm not exactly looking at the core restart issue, but I'm seeing basically the same issues when we run at scale. And I think the cases are kind of similar, where we have multiple flows that get added and removed at the same time, and we have some bounces. Then we get into some cases of mismatch between the barrier request and the IDs.
So Theo, we were discussing yesterday about the OF agent Go routines that we found. Did you get any update on that?
Yeah, removing the nested Go routine seems to help a little bit, but doesn't completely fix the issue.
I see.
So I'm still seeing cases in which owners complains about an XID mismatch, meaning that we received messages with an ID that we're not expecting. And I'm still tracking down how and why that happens, because with that, removing the Go routine looks like that OF agent is behaving in the expected way. So it's correctly processing the barrier request and reply without overlapping anything and maintaining the right order of messaging. Okay.
Then I think that's a first step. Maybe we can try that change and see if David sees any better behavior.
I think David has tried the same changes in his setup.
This is the removal of the Go routines?
Yeah.
Yeah, I've tried that, and when I try that, what I'm seeing is, and I'm not sure it's consistent, that on the core restart in ONOS, I never see a reauthentication in AAA or new DHCP request, and flows are in pending state. So there still seem to be issues even with that.
Are you guys sure you removed the same Go routines?
No, we're not sure. And if Theo, if you I don't know, give me a patch or point me at somewhere I can try it.
Yeah, I'll push an image somewhere.
Okay.
Can you also push a small patch, Theo? Do you mind?
Yeah, no problem.
It seems pretty straightforward that we should push a patch.
Or just send me a diff or something.
Yeah. Sounds good.
Yeah, okay. So I think a next step on that is, well, you maybe test this, and then we go even deeper in the analysis with you, Theo. And yeah, we go from there. Any other thought? Ken, you wanted to say something?
Yeah, sorry, I I joined later. The notification didn't show on my calendar. So I need to add that one. So pretty much it's like I'm starting to look at all the failures that we have seen, and I'm trying to see if it's. I know we are talking about the flow errors, flow pendings issue. I think there's also another issue in the sense of when we do a restart of the core, there is not both adapters are up at the same time. And when we get a flow request from ONOS that comes down, then the core will take it and maybe we'll try to send it to both adapters, like if it's decomposed for the child adapter and parent adapter. In one of the things that I've shown before was the flow make it all the way to the child adapter, like the ONU adapter, but the vOLTHA adapter was not ready at that time, so that fails. So because of that failure, the core just removed the flow from the ONU adapter and send a notification back to ONOS. So because of the speed with so many flows coming in, there is a potential issue where I won't say it's an issue with the adapter per se, but it causes failures, multiple failures, because the multiple add and delete into the ONU adapter. At one point of time, it just like says, "Hey, I can't hold it because why you're adding and deleting all the time." So there is this situation where when both adapters are not up at the same time, or when the flow is coming in, it can cause that problem. So it's something that I'm looking into and see if that's the root cause of the problem that we're seeing with flows.
Are we processing kind of the barrier semantics all the way down to the adapters? I mean, when a barrier message comes into the OF agent, everything up to that barrier message should be processed all the way down to the adapters before anything else is processed. I'm just wondering, with all the various Go routines through OF agent, core, and adapters, if somehow we're not honoring the semantics of barrier correctly.
We are, as far as I have seen in the code, the barrier is only cared about in the OF agent, and that means that the message is not sent to the core till the core acknowledge the previous all the requests in the previous barrier. But the core acknowledge those requests when it sends them to the adapter. Then the adapter may still be processing them. Is that right, Ken?
The core, whenever a flow request comes in, it goes to the OF agent. And if it's a binary request, like you said, it doesn't make it to the core. All the core sees is if it's a flow add, flow delete, or whatever. And then the core will send that request to the adapters. It will reply back to OF agent, says, "Yep, I got it." But then later on, if that flow fails, for example, say flow add, if it fails, then the core will send back a failure message, open flow error message to OF agent that gets back to owners. But if there's a success, like for example, the flow has been added successfully, then there's no response per se, another response to owners for that. So there's a failure response if there's a failure. Otherwise, there's no other response other than the first response that the core got it.
Yeah, but it's not really a response. It's an asynchronous message that is totally fine according to the OpenFlow specs. But the OF agent doesn't wait for that response to arrive before moving on to the next step.
Yeah.
Yeah, so that would say the barrier semantics aren't honored. For while it may not be preference and it may be an issue in performance, messages are essentially need to run to completion when I hit a barrier, and that means completion either success or failure.
Yeah, that barrier per se, the OF agent needs to have information to say that this flow has been fully processed. I don't think at this time the OF agent has the full information to know that a flow has been fully processed, other than in a failure case.
I guess the question is, particularly with using gRPCs now, can we make this process synchronized? Because I mean, that's messages kind of are synchronized, right? I mean, they come from the controller. They're supposed to be processed all the way down, and then a response up. And when a barrier hits, those responses all have to be successful all the way down to the device, and back up. So maybe that means in terms of the processing, we need to find out where we're executing Go routines, both at the all three levels, if you will, and maybe, I don't know, queue eliminate, I don't know, do something to support run to completion.
That can definitely be done, because in the core, when we send the request to the adapters, we start a Go routine. So if we could easily change that code, well, easily, it's easy, it's easy to say easy.
Yeah.
It's pretty much, it's instead of, because we start a Go routine and then we wait for the response. And the response is the actual response from the adapter. So if it's a barrier request, we don't need to start that Go routine. We just launch it and wait for the response, and then send the full response back. So it's feasible.
So, but wasn't that the case a while back, and we moved to the asynchronous processing to achieve the scale that we needed?
Yeah, it was, but the problem is, you know, it's, if the concurrency we're implementing right now violates the behaviors of OpenFlow such that we're not correct in terms of execution, you know, what's the trade-off?
Yeah, no, I totally see your point. I just wanted to make sure that we're not going in circles. Totally makes sense to.
Yep, and it might, I mean, for normal processing, I think we could probably get away with it, because normal processing says, look, messages are going to be handled. No, I don't know. Could we? Do messages have to be handled to completion? I mean, if the issue is queuing them up, they can be queued up all the way down. And then if we hit a barrier, we can, you know, say, okay, that changes how we process things. I don't know.
So I see the issue most of the time when the flow delete is involved. When the flow add is involved, that seems to be a pretty straightforward case. And I wonder if that's related, if that's somehow related to the fact that we send an add to the adapter, and if that fails, then we try to remove the flows from the adapter, and then the flows come back again, and we get in this loop in which we cannot complete those operations again.
Yeah, this is the scenario that I was seeing with the two adapters not ready at the same time, around the same time when the flow was there. So this is something that I'm looking into to see if it's if that was one of the situation that was making that issue even worse.
Yeah, I'm saying pretty much the same thing while running at scale, because it's basically the same case where you have a bunch of flows that arrive together, and some of them times out because they cannot all be processed at the same time. And then we get in this loop in which we keep trying and removing flows.
Yeah, so really it's in normal processing, if we have a lot of flows coming in, assume no adapter, no call, nothing goes down, if there's a failure, the current processing, and for example, for flow ad, the current way we do things is if the flow ad fails, then we're going to remove it from the adapter. And that's something that if at scale, we're seeing a lot of those flow ad failures, then do we want to stop removing them? Because the problem is, if we don't remove them, then that's, the adapters will have certain flows that we don't want to have. And then what do we do with the flows in the core? Do we remove them as well, or leave them there, which is incorrect? So it's the process. I think the process of add and remove somehow needs to be there. It just under load condition, we need to figure out like why we are seeing that level of failures.
Yeah, I think we need to investigate why the failures are there in the first place.
So if I send an ad and a delete, or delete an ad, they should be able to be processed in any order unless I do a barrier, right? And if I meant to delete it and it deletes processed before the ad, then the flow should be there. And it's up to the controller to determine, right? Is that the spec from OpenFlow? Or if I send a message, add delete, are they supposed to be processed in order by the switch? And if they're supposed to be processed in order by the switch, then we have to start guaranteeing order, which we don't do today, all the way down through the device. So I think this goes back to kind of the OpenFlow model. Right? What's the spec say in terms of ordering? Anybody know offhand?
Looks like it's something that we need to look into.
Yeah.
Yeah, agreed.
Yeah, I wish I had a straight opinion, but the more I look into it, the more confused I am. So
It's okay here from the spec. In absence of barrier messages, switches may arbitrarily reorder messages to maximize performance. Hence, controllers should not depend on a specific process in ordering. In particular, flow entries may be inserted in tables in an order different than that of the flow mod messages. Messages must not be reordered across a barrier message, and a barrier message must be processed only when all prior messages have been processed. So that says to me that within a barrier, so within a group of messages, they can be reordered, but they can only be reordered for performance reasons, which means if we're reordering a delete and an add, we've changed the semantics, not performance. So that's not allowed.
but it's
in any
as far as
case,
I can tell, we always get a barrier between a delete and an add.
yeah, I think I'm almost certain actually that ONOS does send a barrier between two different types of flow operations. So an add followed by a delete. In the middle there's always, I'm like 90+% sure that there is a barrier in there. I can double check, but I'm almost certain that there is a barrier in there.
And that might be a configurable option on ONOS as well.
Maybe, but as far as I recall, the default is that you're gonna get a barrier. Which
Okay,
is what
and that's fine. But that says to me that we're not honoring barriers correctly if we're seeing flows reversed.
We need to understand who does the reordering, because at this point, if the web agent doesn't, it's most likely the core. And where?
Yeah, I agreed. I suspect probably what's happening is somewhere down the line we're launching Go routines arbitrarily and that's causing issues. And I don't know, that could be in any, agent core adapter all the way down.
Well, the barrier request doesn't make it into the core and the rest. So it's that's the first thing
Yes.
into us, right? Like we need to make sure that the barrier that the spirit of the barrier makes it into the core.
Well,
and that's all it.
yeah, yes and no. The barrier can stay in the OF agent, in my opinion, because the OF agent ensures that when the core returns from the flow add or flow delete method, that is weighted. So the return of the core on the method is weighted before sending the barrier reply.
Yeah, I understand that. What I'm saying is like when I talk, I'm not saying the message itself, but something needs to tell the core, okay, for those kind of messages, you need to wait for a full response before you reply back. At this time, when the core get a request come in, the flow add, for example, the core will decompose it, send it to the adapter, and just say an ACK, return an ACK back to Earth agent. So that flow may not have made its way fully into the adapter at that time. Because and even if there was a barrier request, the core doesn't know it. So the core needs to have something that tells it, okay, for this message, wait for a full response from the adapter before you send me back an ACK.
Mm-hmm.
Or if it want it to be async, the core will need to wait until, even if it does it in asynchronous way to send it back to send those messages to the adapter, it needs to have this thing that says, okay, use that transaction ID and say, okay, the flow was processed correctly. So there should be something coming back from the core when there's a barrier request that says, okay, this has been processed fully. At this time, there's none.
Mm-hmm.
So that's what's missing.
Okay. Then I think we can continue the investigation, and we can report back next week and see what's up. Would that be fair? And in the meantime, Theo, you can submit the batch for those initial goal routines to take them out and see if they correspond to what David found. And we can progress.
Yeah, I sent it already. I posted it on the gRPC channel.
Okay, thanks. Great, perfect. Okay, so next up is a topic I wanted to bring up to everybody, so everybody knows about this. There was a patch in the recent days that introduced some parameters in the Helm charts that enable you to deploy a vOLTHA stack within and enforcing the presence of all the pods within the same Kubernetes node. So that was from Andrea and Amit, and that was a DT request. The patch is already merged. It does not affect existing deployments because it's a configurable parameter and it's turned off by default. But I wanted them to share the reasoning behind this patch. So Andrea, Amit, you want to say a few words?
Hello, here's Andre. I'm not sure if Amit is also listening. So basically, the idea was to optimize the distribution of the ports in the sense that if we have them always, or like the ports belonging to the same vOLTHA stack, if they're on the same node, then the communication path between the parts of the vOLTHA stack is shorter because it's on the same host. And then, of course, this will increase the speed for communication. Another reason is the actually stability consideration. Because if you imagine that one node fails at some point, or is restarted, or whatever, is like some maintenance happening to it, then if some parts of the vOLTHA stack are not available in the pod, then the whole vOLTHA stack can be considered unhealthy. And then it doesn't make sense, right, to distribute them like randomly over the nodes, because if one node is restarted, then the chance of vOLTHA stack to become unhealthy is quite high. But if they are scheduled on the same node and that node is not restarted in this moment, then of course like all the functionality belonging to this vOLTHA stack stays healthy. And of course, if this affected node is restarted, of course, then it also becomes unhealthy. But if you calculate the chances, right, like how often it might become unhealthy, then the chances for the vOLTHA stacks scheduled on the same node are higher or better than for the like randomly distributed pods. Also, additionally, the change there is trying to, or like it's also optional, but with the flag you can also say that the vOLTHA stacks should be, if there are many and you have also many nodes, then each new vOLTHA stack is deployed on a not occupied node by another vOLTHA stack. But of course, if you have more vOLTHA stacks than nodes, then it still will be scheduled because it's a soft requirement, and it's possible to to schedule even like, or let's say break this rule, right, this scheduling rule, because it's a soft requirement. But anyway, if you have, let's say, 3 nodes and 3 vOLTHA stacks, then this rule will try to schedule them on different ones, also following this optimization path. So that's in short the reason. I don't know if Amit can add something to what I said, or maybe there are questions.
I think you've covered everything.
You're just using affinity to guarantee no two stacks are in the same. And
Yes, affinity and anti-affinity. So we use both.
okay.
Yes, and of course, in our DT setup, we will enable this option, right, for the optimization reasons. But as it was already said, it's disabled by default.
So a single stack is going to be on a single node, but multiple stacks each will be on a separate node.
Yes.
Okay. And what happens if I have 3 nodes and I deploy 4 stacks?
So as I said, this requirement is not a hard requirement, it's a soft requirement. So then I guess the Kubernetes will select a random node for the 4th stack, or
Okay.
maybe the first one. I don't know. The rules are unknown to me, but it will
Okay.
not it will not fail. Yeah, it will not fail for sure. Yeah, it will be.
Okay,
scheduled.
that's the important one. Okay.
Yeah. So that's it from my side.
And one thing we haven't talked about, and maybe related to this a little bit, or haven't talked about in a while, is moving a stack to be a pod. And what I mean by that is a stack is the agent, the core, and the adapters that core uses. Because we're not using any HA throughput, any HA capability on a single stack, we're not running multiple adapters or anything like that. Effectively, we're running those components as a single pod. And if instead we defined a stack as a single pod, then Kubernetes would automatically deploy a single stack on a single node together. And then we would just have to do pod affinity to keep them either on or on separate stacks rather than deal with each separately.
I totally agree to that, because when I was trying to like bring this change to life, I also thought about sidecars, right? So containers running in the same pod, because it would be like even more optimal approach. Then you don't need these complicated rules, right? And you also don't need so many Helm charts. You just need one.
Yes.
And yeah, I would totally vote for this change, and maybe we can create a ticket, and I can work on that as well.
Yeah, I personally like prefer the pod approach for all the containers, and because for gRPC, for example, the gRPC work will make it just much easier for the pods to communicate to each other rather than via a service. So if there is a failure, for example, we don't have to. It doesn't go for a service. It doesn't take time. We will know right away if the other end is out or not. So it will definitely help in terms of the gRPC migration.
And if we chose to get rid of some of the configuration around specifying endpoints, that would work too, right? Because they essentially all go through the local host, don't they? If they're all in the same pod,
Exactly.
or not local host, but yeah, local networking, which
Moreover,
may have some performance implications as well.
So moreover, we can use sockets to speed up the communication even more, because then it will be like, yeah, amazingly fast. Yeah, I think it's more faster than TCP approach.
I think we'll still probably have to have kind of the event bus Kafka for asynchronous messaging. Have we determined that's going to be external to, well, it probably should be external to the pod, or at least configurable to where it is.
Yeah.
But I'm just so specifically, I'm talking about OF agent core and the adapters in a single pod.
So one question I have about that is, so currently we assume that all the pods or all the containers are going to be in the same pod. How easy is it going to be to change, for example, the adapter to be a separate image? Because right now it's very, very simple. You just change the Helm chart, deploys a full new adapter with full new options, values, configurations. It's totally a separate thing. If we add it inside one pod just as a container and an image, how easy is for this type of configuration, and like maybe completely random new value files, values for the environment and things like that can happen? Because that is the case, for example, for the action adapter for
It's a very valid question. I know Kubernetes can restart in failure scenarios to containers independently. I personally, I don't know if anybody else knows, I'd have to verify if it can deal with an upgrade of a specific container within a pod.
To me, it's not just an upgrade, but it's even like a first-time installation with different values that are not the ones that are specified in the standard normal Helm chart for the whole.
Well, it would, yeah, you'd still have an image for each container, so that could be changed via values file.
Yes, agreed. But it might be that you need some more parameters, and if those parameters are not specified in the Helm charts, you would have to rewrite the whole new Helm chart just because you're changing the image. And that whole new Helm chart means rewriting the whole Helm chart for the core, the OF agent. The one Helm chart needs to be completely duplicated because you have some more.
Right. We have a new Helm chart, but yeah, we'd have to make sure we have those values parameterized. I would agree.
So I think that's the downside. We limit a little bit ourselves in terms of ease of deployment whenever it's not the standard set of containers.
I'm not sure we do. I mean, if the new Helm chart includes parameters for each image, I think we have the same capabilities. Yeah. Again, assuming Kubernetes can restart a single container at a time within a pod for an upgrade or a change of image.
Yeah.
But so what I think is like, even if you restart one container, or one pod, then the whole vOLTHA stack is unhealthy because they cannot function like if some parts are down. So it's a whole brain, right? It should be up and running. So, and in this case, even if you change one container, it's okay to restart the whole pod because of update, because anyway, they will be not functional. Partially.
Indeed, it might be okay. I was more concerned about really the startup with a completely new image, with completely new values, not just restarting pods within, not restarting container within the pod. That could be an issue. We could have to deal with that. We currently have the capability to restart each one of them separately. And I like that, because if one fails, we don't have to restart the whole thing. And we do less requests to a TCD, for example, during the restart period. There are pros to having them separate. We just need to evaluate the pros and the cons. There are a lot of pros in having them united in the same pod, as you guys have outlined, but there are some cons that I already see. So it's an evaluation. We can certainly start an evaluation process on this, but I wouldn't say, okay, let's do it.
Additionally, in case of different types of adapters, ONU adapters especially, if you have different types of ONU adapters and you restart one, you may work with the others.
Yeah, that's very true. The minute we start using other adapters other than the open OLT adapter, this becomes, you might have a different pod definition.
So new adapters, and also a non-one number of adapter. So if you have like 5 OpenOLT adapters and 5 OpenVNU adapters, we had that in the past. We don't do right now, but it might be that we go again for that solution in the future. The single pod stays a little. It seems a little too strict for us. Maybe not. Again, as I said, pros and cons.
Yeah, I agree. I think it's something to talk about. I'm not saying that we should go off and do it right now. It's just, I think, something to discuss.
Yeah, maybe Andre, if you want, there's that. I definitely do see value in trying to understand what are the pros and the cons, and you could start a possible document on what you see as the pros, and we could put in pros and put in the cons in there as well, and then make a final decision. Something that I also wanted to mention, this is a general VOLTHA roadmap thingy. This is most likely not going to happen in either in 2.9 for sure. Maybe if we decide that it's important, we do it in 2.10, but again, definitely not in 2.9. In 2.9, I want to stabilize. The one big architectural change is going to be the gRPC swap, and that's it. We don't make any other changes from an architectural perspective.
Okay, yeah, I totally agree.
The one thing that this change, it's more a deployment model. It's not really like changes in the code per se. So it can be done anytime.
It can be done anytime, yes.
So it's not really a code change, the deployment change.
Till you decide to use sockets, then maybe you need to change the code as well.
I'm not sure we're going to, I mean, they're in separate containers still, so I'm not sure if we could actually use sockets or not.
Yeah.
No, we can for sure.
Like
I mean, technically they're using sockets anyway, right? They're just network sockets. But you're talking about using, they're not, you'd have to give them permission to open up sockets on the host.
No. Only inside of the pod, yeah, or inside of the container.
Okay, I'd have to understand more of that because they're separate containers still. So there's separate network spaces within the host.
But they share the same virtualization, right? Environment,
Yeah.
and they can access for sure same socket.
Okay.
Okay. So Andrea, why don't you start the document on that, and then we can discuss it in the next time. As Ken pointed out, in theory, you could have a Helm chart that does it, and it's not just maybe the preferred way of doing it. We just have it on the side and say, if you're interested, you could also do it this way. I don't see actually a complete problem with that, but
you need to support, you need to maintain both versions.
yes,
right?
indeed.
No effort, yeah.
Yeah. Okay. Next up, let me just give an update to everybody on the deprecation of the old and used repos. Actually, there is a Jira that I forgot to put here. I found many more, and I just closed them all. Let me just find that Jira. There are now every one of those repos has been added a comment where it says this is old code, it's not maintained. Don't wait for us on anything. There's no support on this, blah blah blah. And also they are being closed on Gerrit in the sense that they are being placed on read-only mode. And that is so that no pushes can be done to those repos. If anybody is interested on the full list of the ones that I closed, it's this one. It's this list over here. And you can see the patches over here if you're interested, just on the ones we closed. If you think there's something else, I couldn't find it, but if you think there is something else vOLTHA related that is not used anymore, just drop me a message and I can do it as the others. Okay, so this is done. The next two items are the MPLS and the OpenOLT core, open core OLT app rewrite. Theo, do you want to give us a 5-minute quick update on the rewrite of the OpenOLT app?
Yeah, I'm still proceeding with that. I haven't made much progress since last week because I've been spending most of my time looking at the flows. One thing that I've done is to start using the distributed primitives in ONOS, and that seems to be a smooth transition. I've done a couple of runs at scale, and when we don't hit the flows issue, yeah, it works fine. That's pretty much it.
Great. Yeah, I've also started a review of the code myself, going through it and helping Theo with some clarifications and things like that. So we're doing some good progress, I think, on that front, and it's going to be a very good change. The app is much simpler. We're going to make sure that everything is supported. But we are going to announce it whenever it's ready for common use, and we could also probably produce a vOLTHA image at some point. We will also produce at some point a vOLTHA image that people can try out and let us know in their daily workflow if they have something that they find that doesn't work or things like that, because everybody maybe uses it for different things in a different way and different workflows and things like that. So we're going to do that as soon as we have something that we know it's usable for 3 workflows. Okay. On the MPLS support, we merged the OFAgent patch that supported the changes for the flow mods instructions that came down from ONOS. The core patch is also ready. I was waiting for a review from Ken to just go ahead and merge that one as well. These do not impact any other functionality. It's just that it adds the capability to understand more elements, and in particular the MPLS labels. Amit, anything you want to share?
No, Andrea, there's nothing new to share out there. I think we already discussed about this in the previous calls. So.
Okay. Is there any update on the support of the MPLS on the Adtran front and on the ONOS side? Because we have the patches for respectively the everything that is public, meaning the web agent in the core, except ONOS. So is there any update over there?
On the admin side, I believe they are working on that. So we did have a discussion with them on the changes that we did with respect to the number of flows in the upstream, and they're going to absorb the change as well. On the ONOS part of things, right, there are two changes that needs to be done. One is in the vOLTHA app, as well as in ONOS itself to create the extensions. Those need to be scheduled. They are not yet scheduled. Those are activities.
Sounds good. Thanks. Okay. That was all that I had for today, at least on the agenda. Anything that you guys want to bring up before we close the meeting? Okay, then we get 10 minutes back, which is always good. Thanks for the discussion. I think it was really, really good. We have our action items for the different stuff that we're working on. So I'll let everybody work on those. And let's keep us updated on Slack and on the mailing list. And let's talk again next week. Thanks, everybody.
Andrea,
Cheers. Yes.
so
Yes,
sorry
Mario.
for interrupting for everybody. Just this came to my mind later when discussing about the gRPC, Kafka to gRPC change.
Yeah.
We discussed about, different things, and one of them was, changing the processing, like, from asynchronous to synchronous calls. I want to remind an issue there, because I think, Chen and David and others will, investigate the issue. When a service provisioned from the ONOS side, it mostly end up with two or more flows. And one of these flows is pushed to the vOLTHA adapter, and the other one is to the ONO adapter. And these flows are directed to the correct adapters in the RW core. But the thing is, ONO adapter does not process its flow because it waits vOLTHA adapter to finalize the processing of its flow and send technology profile download message to ONO adapter. So ONO adapter waits to process its flow until this download technology profile message is received and processed by ONO adapter. Then it processes its flow. So I only wanted to remind this because this is important issue for ONO adapter to process the messages correctly. If you change this asynchronous processing to a synchronous one, then you have to first push the flow of the vOLTHA adapter, then be sure that the vOLTHA adapter finalizes its flow processing and send the message, technology profile download message to ONO adapter, got the response and set the response back to RW core, and then the ONO adapter flow should be pushed to the ONO adapter. Okay.
Yeah.
I'm trying to understand, is this a single flow that's being bifurcated to the two devices?
This is, in some cases, as far as I know, in some cases, it's single flow sent by the ONOS to the RW core, and RW core composed with two adapters. But this is general case in control plane flows, for example, DHCP kind flows. But for data plane flows, as far as I know, there are two flows generated by ONOS separate.
Okay.
So there are two kinds. Both of them are valid for our system.
Yeah. So from a core perspective, that shouldn't be an issue. Because when we are talking about going synchronous here, it's really the interaction between OF agent and the core, especially when we have a barrel request there. In the core, the flow that comes into the core, it's a flow to a logical device. So the core at that point, that's where the decomposition happened, and then they send to different managers and then those are the ones that send it to the adapters. It's a logical agent itself that waits for the responses from the ONU adapter and the OLT adapter. So it's that process will not change. That it will still have to wait. If we want to have a full response back to the OF agent, then it's the logical agent that will wait from that. And in fact, if there's any failure in any of those adapters, the action to revert that flow, it starts from the logical agent again. So I don't see that as an issue.
Okay, I mean, yes, I mean, if you, I mean, try to change your, I mean, way of implementation to wait the one response from one adapter, then send the, I mean, other without, I mean, without go routines in a synchronous way, then you may fail to do this if you first send the ONU adapter flow and then later OLT adapter flow, because the ONU adapter will wait to OLT adapter to complete and will not send a response until you get the technology profile download message from OLT, which RW core, I mean, will do later. I don't know if I mean, told it's correct or not, but
So
this should be taken care when I mean changing the implementation.
okay,
If you need to change, I mean,
the only time where this could be an issue would be if we decompose the flow, we send it to the device, to the adapters, which send it to the devices, and then the ONU adapter needs another flow from ONOS to keep proceeding, then that may be an issue. But if all it needs is flows that has already been sent to the OLT adapter, then I don't see an issue. If it gets synchronized at the logical agent level. I am being clear, or is it more confusing?
Yeah, it's clear to me, but I didn't see Mahir's point on why rewrite core has to synchronize technology profile messages. That's what I understood. To me, what Ken said, you know, that should work. I mean, as long as logical device manager waits for both flows, I mean, the ONU and the OLT adapters to respond back and then respond back to OF agent, yeah, that should be fine.
yeah, I mean, in itself, yeah, if it sends the flow add messages to OLT adapter, ONU adapter asynchronous and parallel, and waits the parallel responses from them, then it's okay. I mean, if you want to change this implementation to send the message to one adapter, wait response, and then send it to the other adapter. Okay. If you change the implementation in this way, then you have to be, I mean, careful to implement it in the correct order.
Yeah, yeah. I at that level won't change that. It's that implementation will remain. I don't think we'll change that, because that will require a lot of inherent knowledge of the type of flows in the core, and we don't want that.
By the way, to me, it's the security. I mean, the most reliable way to do the things in vOLTHA. Current implementation, I mean, cause a lot of problems, because this async messaging and async messaging going from one module to other one, and then from this second one to third one, and we have to, I mean, do this asynchronous messaging in between them, all of these processes, causing a lot of troubles, I think.
Yeah, I think the issue isn't so much synchronous processing as each message needs to run to completion before the next one is processed. So messages at the high level, at the OpenFlow level, have to be processed to completion, and that's synchronous at that point. If there's concurrency happening below that, talking to the different adapters, that's perfectly reasonable, as long as we can know when the complete OpenFlow message that originated all the calls is complete.
I agree, yeah.
Okay. Well, then I don't think we need to do anything on this point right now. There might be a tie-in with the changes that we might need to make in the OpenONU Go adapter to have some more synchronous flow processing, but we're going to talk about those tomorrow at the call of the OpenONU adapter. So I think we're good on that front. So thanks, Mahir, for bringing this up nonetheless.
You're welcome.
Okay. Anything else, guys? Okay, then if not, thanks everybody for joining, and I'll talk to you again next week. Cheers. Bye-bye.
Okay, thanks. Bye.
Thanks, bye.